So we're going to continue chapter 6. This is 6.3, and we're looking at logarithms and their properties. So all log functions are the inverses of exponential functions. So if our standard exponential function is e to the y equals x, then the log function reverses that, and it's y equals log base a to the x. I remember it with a b and an a because in my head I can go, well, b is the base, x is the exponent, a is the answer. So when you redo that, log of the base or log base of the answer equals the exponent. So that's how I remember it, but really it's just that they undo each other. So if you had 2 to the third equals 8, the 2 becomes the base, the 8 goes next to it, and then the exponent becomes the answer. Same thing here, here, and here. It's just you're able to rearrange those automatically without having to do the whole thing. So if we were solving this, 8 is going to be our base, x is going to be our exponent, and it's going to equal 4. Then we solve these just like we did in 6.2. Just checking it's still recording. Yep. So we make the bases the same. So this would be 2 cubed, and this would be 2 squared. So if we multiplied exponents, we'd get this. And since the bases are the same, the exponents can be the same, and we can solve. So x would equal 2/3. So if we did that again with b, x to the 4th equals 16. So we would take the 4th root of both sides, and it's even, so we're going to have a positive or negative answer. 4th root of 16 is 2. And now you can't have negative bases for your log, so it's just going to be positive 2, because you can't have a negative. C, it'd be 4 to the 3/2 equals x. So if you typed that in the calculator, you would get x equals 8. So sometimes it's easy to just go back and forth by using your base, your exponent, and your answer to solve. So whenever we write log, we have our base down here. If there's no base, it's base 10, because that's the numbers we work in. So if it just says log of x, it means log base 10. So if you were to type these in the calculator, the log button's usually off to the left. You just type log 2. So when you hit that log button, it's automatically dealing in base 10. So if you type log 0.1, this gives you the answers that you're looking for. So it's just practicing typing it in. ln is called the natural log. It's the same as saying log base e. Remember we talked about e with the interest? So to instead of writing base e, they write ln. So one inverse property here is if your base is the same for the log and the exponent, they cancel out. If your base is the same for the log and the exponent, they cancel out, and then that exponent is just your answer. We'll get into that in a little bit. So if you were to evaluate the natural log, that button's also on your calculator as ln. So you can just plug those in. ln 12, ln, and then remember your e was that second button. Well here, if this is the same as log base e, and then you're doing e to the 10th, these are going to cancel, so your answer would be 10. And then same thing for C, they cancel out. Same thing for D, those bases cancel out. So you don't even have to put them in your calculator if you recognize that those are the same. Properties of logs. If you're taking the log of 1, it always equals 0. And if we think about that as our inverse, we'd write a to the 0 equals 1. Always true. Anything to the 0 is always 1. Then we were just talking about that. The base and the exponent cancel out if they're the same. And it works the same this way. But because of that, k has to be greater than 0. Because negative exponents do all that. So logs, you can't take the log of 0. It's always greater than 0. There's ways you can rewrite functions, and they're called the product rule, quotient rule, and power rule. If you're multiplying two things in a function, you can break it apart with addition. If you're dividing, you can break it apart with subtraction. And an exponent can be rewritten in the front as a coefficient. So that helps you rewrite and solve when you're looking for certain things. So let's try some. So this is multiplying. So we can rewrite this with addition. B is dividing. So we keep our log 9, we keep our base, but then we subtract the pieces inside it. So that's how you'd rewrite those. Here, rewrite our square root. So if you remember, square roots, this become fractional exponents. The number over here becomes the numerator, and the index in front becomes the denominator. So you can always rewrite fractional exponents and radicals. So if we rewrote this, it would be log base 5 of 8 to the 1/2. Then we use the power rule to bring the 1/2 in front. So it's 1/2 log base 5 of 8. Decimals we can rewrite as fractions. A fraction like this it's the same as saying 10 to the -1. Here our bases are going to cancel, so this would just equal -1. And then if we look at this, our bases are going to cancel, so it would equal 3. So sometimes they're a lot more simple to rewrite than having to do it all out if you know those rules. Okay, let's keep going. Let's try some longer ones. So here we have multiplication, division. So we're going to subtract the bottom, or the top minus the bottom. And then this bottom one we can break into an addition problem. A of x. So this would be log AY plus log AZ. Then we distribute that negative and get log AX minus log AY minus log YZ. Log AZ, sorry. So we're just using the rules to break them into multiplication, division, and go from there. So G, we're going to rewrite it with our exponent. So that would be 2/3. And then we just bring the 2/3 in front because it's an exponent. And there we go. That's as far as we can get it. So let's try one that has more pieces. So first, I want to do the exponent. So this would be x cubed, y to the 5th, z to the m to the 1/2. So we're going to bring that 1/2 in front and get rid of the exponent in the log. Now we're going to break apart these 3 pieces. So we're going to leave the 1/2 out front and use the product rule for the numerator, and then subtract the denominator. Now we're going to use the power rule for each piece in here. So we bring each exponent in front of its log. Now we're going to distribute the 1/2 to each piece. So 1/2 times 3 is 3/2. 1/2 times 5 is 5/2. And 1/2 times m is m/2. So now we've broken that apart as far as we possibly can from the original. And if we knew the letters, whether we plugged it into the calculator like this or like this, we would get the same answer. You can also go the other way. If it's broken in with adding and subtracting, you can rewrite it using those rules and turn it into one piece. So these all have log base 3, so we can do that. This term and this term are added, so we can do multiplying. And then the last term is subtracted, so it would go on the bottom. And that you could distribute the x, or you could leave it like that for this purpose. For b, the numbers in front become exponents. So this is the same as log a m squared minus log a n cubed. And that subtraction tells us division. So we do m squared over n cubed. So those are just a bunch of ways to break them down. Let's see what else we have in here. Okay, here we go. So we're going to take this one and go the other way. So we're going to bring each piece as an exponent. Log b 2n to the 3 halves and log b m squared n. Now we're going to use our adding and subtracting to make a multiplication and division. So these two are going to be on the top, and then m squared n is going to be on the bottom. Now we're going to keep going because we want to try to get rid of the fraction exponents here. So I'm going to distribute this to the 2. Oh, that should say log, not LG. Log base b, m 1/2, 2 to the 3 halves, n to the 3 halves. Now, when you have a fraction with the same bases, you can subtract the exponents. So if I do 1/2 minus 2, I get a negative half. So that goes on the bottom. There's only 1 2, so that's going to go here. And then n, 3 halves minus 1 is 1/2. Now, all of those exponents are divisible by a half, so I can kind of reverse distribute that. So it would be, if I take 3 halves divided by 1/2, I get 3. For n, 1/2 divided by 1/2 is 1. And for m, 1/2 divided by 1/2 is 1. So I'm left with that 1/2 as an exponent out there. Well, 1/2 is the same as saying a square root. And 2 to the 3rd is 8. Where did I get 1/2 minus 2? Where did I get the 2? Oh, okay. So way back here, I lost my 1/2 minus 2 is really negative 3 halves. So this should still be a 3 and this should still be a 3. So it's a lot of steps, but sometimes that rearranging makes it look a lot better when you're done. Change of base. So your calculator only works in log 10, base 10. So sometimes you need to change it before you can put it in your calculator. So if you're trying to change the base, you can create whatever new base you want. The original base becomes the base or the bottom of the fraction, and the answer becomes the top. So if I wanted to make log base 7 of 5 into log 10, I put the answer on the top and the base on the bottom. Now I can type this in my calculator as a division problem. So if you look over here, remember your base goes on the bottom, your answer goes on the top. So you could type it log base 17 over root log 5 and you'd get an answer. You could change it into the natural log and you'd get the same answer. Or if you have a calculator that can do the base of the logs, you would get that answer if you typed it right in like that. So there's 3 different ways. Doesn't matter how you change it, you get the same answer. Same thing here. It's just another example showing you. The base would go on the bottom, and then log of the answer would go on the top, and you can use whatever log you want. So that is 6-3. Let me know if you have any questions.